Hello friends, welcome to Electrical Design Engineering YouTube channel. You can watch my videos in your language. Follow the steps to set your language. Step 1. Click the gear icon. Step 2. Select audio track. Step 3. Select your language. You may contact me for industrial design substation layout power system studies on +9 1700 647 4688, call or WhatsApp.
Hello friends, this is our lecture number 58 of our free course ETAP. In this lecture we will study about power system stability and its classifications. If you have any question after watching this video, you can ask through Google form. The link is given in the description. What is power system stability? The stability is the ability of a system to return to its normal operating condition after a disturbance. Power system stability is defined as the ability of a power system to return to its normal operating conditions after a disturbance while continuing to work safely and properly. What is disturbance? A disturbance is any sudden change, expected or unexpected, that affects the normal operation conditions of the power system. For example, faults on the network. These are the sudden changes. Faults come suddenly, so this is the disturbance. Loss of generation. For example, when a generator trips or when a part of the power grid fails. Load changes, like sudden adding a large load or disconnecting a large load is also considered as a disturbance. Starting a large motor which draws a heavy starting current and cause noticeable voltage drop in the system. We have studied in our motor starting studies that when we start the motor, they will draw very huge current initially. These huge currents may cause a noticeable voltage drop. So starting a large motor is considered as a disturbance. Transmission line outage. That is the loss of the line due to the maintenance work, equipment failure, or fault on the line. The power system stability is classified into three parts. One is the rotor angle stability, another is the frequency stability, and third is the voltage stability. Rotor angle stability. Rotor angle stability is the ability of a generator to stay in synchronism with the rest of the power system. It tells us whether the generator rotor can continue rotating in synchronism with the power system after any disturbance. A generator produces electricity by rotating its rotor at a constant speed, for example 3000 rpm for 50 Hz system. To keep the power system stable, the rotor speed must remain almost constant. The rotor electrical angle, it is position related to the system, must stay properly aligned with the power system. If a disturbance occurs, like a fault, line trap, or a sudden load change, and the rotor accelerates too much or slows down too much, then the electrical angle becomes misaligned. The generator loses synchronism, the machine becomes unstable, and protection relays trip the generator to avoid damage. This anti-behavior, keeping the generator in synchronism with the power system, is what we call the rotor angle stability. Frequency stability. Frequency stability is the ability of the power system to keep the overall frequency close to the 50 Hz or 60 Hz. Frequency depends on the average speed of all generators connected together. If the load increases, the generator slows down, which causes the frequency to drop. If the load decreases, the generators speed up, which causes the frequency to rise. For understanding purpose, consider this is a theoretical example. Two generators G1 and G2 are running at 3000 rpm before a disturbance After the disturbance, G1 slows slightly to 2990 rpm and G2 speeds up slightly to 3010 rpm. In this case, the relative motion between the two machines means rotor angle stability is lost, but the average speed is still 3000 rpm, so the frequency stability is maintained. Voltage stability is the ability of the power system to maintain acceptable voltage levels at all buses under normal conditions and after disturbance. The voltage drop should not be too much, which leads system collapse. The cause of the voltage instability is availability of insufficient reactive power in the system. If the reactive power demand is greater than the available reactive power, voltage starts dropping. The main difference: voltage stability and rotor angle stability. The voltage stability depends on the balance of the reactive power demand and generation in the system, whereas the angle stability mainly depends on the balance between the real power generation and demand. Thank you.